Good morning, my dear cuties. How are you all? I hope you are all safe at your home. Stay home, stay safe. And today we are going to see about our favorite subject, mathematics for the grade 8. We are discussing about the chapter rational numbers, and today we are going to see about the topic properties of rational numbers. What are the properties of rational numbers? Yes, they are closure property, commutative property, associative property, and additive and multiplicative identity property, additive and multiplicative inverse property, and distributive property. What are the properties of rational numbers that we are going to discuss today? Yes, they are closure property, commutative property, associative property, additive and multiplicative identity property, additive and multiplicative inverse property, and distributive property. First, we are going to see about closure property. The collection of all rational numbers Q is closed under addition and multiplication. The collection of all rational numbers Q is closed under addition and multiplication. This means for any two rational numbers A and B, A plus B and A into B are unique rational numbers. That is, if A and B belongs to rational numbers, then A plus B also belongs to rational number and A into B also belongs to rational numbers. Therefore, the addition and multiplication are closure. Let me see an illustration for closure property. First, let us take A is equal to 3 by 4 and B is equal to minus 1 by 2. Now, let me add these two numbers. A plus B is equal to 3 by 4 plus minus 1 by 2. Here, there are different denominators, so we have to convert it to the same denominators. Yes, let me take LCM for 4 and 2. What is the LCM for 4 and 2, my dears? Yeah, it's 4. Already in the rational number 3 by 4, the denominator is 4. So we need not to change that rational number. What is the next rational number? Yes, it is minus 1 by 2. What should be multiplied with 2 to get 4? Yes, it is 2. So we have to multiply minus 1 by 2 with 2 by 2. So it becomes minus 2 by 4. Now the denominators are same, so we can add the numerators. What are the numerators here? 3 and minus 2. What is 3 minus 2? Yes, it's 1. What is the final answer that we get? Yes, 1 by 4, which is also a rational number. Therefore, addition is closure. Next, we check for multiplication. What is A into B? That is 3 by 4 into minus 1 by 2. For multiplication, we have to multiply the corresponding numerators and the corresponding denominators. What are the numerators here? Yes, 3 and minus 1. What are the denominators? 4 and 2. 3 into minus 1 is minus 3 and 4 into 2 is 8. Minus 3 by 8, this is also an rational number. Hence, multiplication is also closure. Now, we are going to discuss about commutative property. Addition and multiplication are commutative for rational numbers. That is, for any rational numbers A and B, A plus B is equal to B plus A, and also A into B is equal to B into A. Let me see an illustration for commutative property. Yes, let us take A is equal to minus 7 by 8 and B is equal to 3 by 5. Now, A plus B is equal to minus 7 by 8 plus 3 by 5. There are different denominators, so we have to take LCM. The LCM for 8 and 5 is 40. So we have to multiply minus 7 by 8 with 5 by 5 and 3 by 5 with 8 by 8. So that we get minus 7 into 5 plus 3 into 8 divided by 40. What is minus 7 into 5? Yes, it is minus 35. What is 3 into 8? Yes, it is 24. So minus 35 plus 24 divided by 40. What is minus 35 plus 24? Yes, it is minus 11. So what's the final answer? Minus 11 by 40. And now we get A plus B is equal to minus 11 by 40. And now we have to find b plus a. What is b here? 3 by 5. And what is a here? Minus 7 by 8. Here also it is different denominator, so we have to take LCM for 5 and 8. What is the LCM for 5 and 8? Yes, it is 40. So we have to multiply 3 by 5 with 8 by 8 and minus 7 by 8 with 5 by 5. Now we get 3 into 8 plus minus 7 into 5 by 40. What is 3 into 8? Yes, it is minus 24. And what is minus 5? Minus 7 into 5? Yes, it is 35. So what are the final? 24 minus 35 divided by 40. And we get minus 11 by 40. Here b plus a is equal to minus 11 by 40. Hence, from this illustration, what we can able to understand? A plus b is equal to b plus a, and hence addition is commutative. And let me see an illustration for multiplication. Yes, let us take a is equal to minus 7 by 8 and b is equal to 3 by 5. Now we are going to find a into b. What is a here? Minus 7 by 8 into b here 3 by 5. Multiplying the corresponding numerators and denominators, we get minus 21 divided by 40. And at the same, what is b into a? Yes, it is 3 by 5 into minus 7 by 8. What is 3 into minus 7? Yes, it is minus 21. And what is 5 into 8? Yes, it is 40. And at the final, we get b into a is equal to minus 21 by 40. From this illustration, what is a into b? It is minus 21 by 40. And what is b into a? It is also minus 21 by 40. And hence, a into b is equal to b into a. And multiplication is commutative. And next we are going to discuss about associative property. Addition and multiplication are associative for rational numbers. That is, for any three rational numbers a, b and c, a plus b plus c is equal to a plus b plus c, and a into b into c is equal to a into b into c. That is, the addition and multiplication were associative for rational numbers. A plus b plus c is equal to a plus b plus c, and a into b into c is equal to a into b into c. Let us see an illustration for associative property. Let's take rational numbers a, b and c. A is equal to minus 1 by 2, b is equal to 3 by 5 and c is equal to minus 7 by 10. And now we have going to prove addition is associative for rational numbers first. A plus b is equal to minus 1 by 2 plus 3 by 5. Here there are different denominators, so we have to take LCM. What is the LCM for 2 and 5? Yeah, it's 10. So converting minus 1 by 2 to 10, we have to multiply it by 5 by 5. So we get minus 5 by 10. To convert 3 by 5 to the same denominator, we are going to multiply with 2 by 2. So we get 6 by 10. And at the final, a plus b is equal to minus 5 plus 6 divided by 10. What is the final answer we get? 1 by 10. So a plus b is equal to 1 by 10. And now we are going to add c with this a plus b. So we get 1 by 10 plus minus 7 by 10 is equal to 1 minus 7 by 10, which is equal to minus 6 by 10. Since 2 is common in both numerator and denominator, we are cancelling it by second table. So we get minus 3 by 5. And a plus b plus c is equal to minus 3 by 5. And now we are going to find b plus c. 3 by 5 plus minus 7 by 10. Here also different denominators. So we have to find LCM for these two numbers 5 and 10. What is the LCM for this? 10. Yes. So what is 6 minus 7 divided by 10? What is the final answer for that? Minus 1 by 10. We get b plus c is equal to minus 1 by 10. And we are going to add a with b plus c. What is a here? Minus 1 by 2 plus b plus c here minus 1 by 10. So here also there is different denominators. So we are going to take LCM for these two numbers 2 and 10. What is the LCM? 10. So we are going to convert minus 1 by 2 to 10. We have to multiply by 5 by 5. So we get minus 5 by 10 plus minus 1 by 10. Here same denominator, so we are going to add the numerators. Minus 5, minus 1. What is that? Minus 6 by 10. Here also there is 2 common in both numerator and denominator. We are going to convert divide by second table, so we get minus 3 by 5. Here a plus b plus c is equal to minus 3 by 5. And from the equation 1 and equation 2, we know we are going to see that a plus b plus c, which is equal to a plus b plus c. Hence it is true for rational numbers. Associative property is true under addition. In the same way, we are going to prove multiplication is associative. Take rational numbers a, b and c, and a is minus 1 by 2, b is 3 by 5 and c is minus 7 by 10. Now we are going to find a into b. We have to multiply corresponding numerators and corresponding denominators, so that we get minus 1 into 3 is minus 3 and 2 into 5 is 10. Therefore a into b is equal to minus 3 by 10. And now we are going to multiply c with a into b. So minus 3 by 10 into minus 7 by 10. What is minus 3 into minus 7? Yes, it is 21. What is 10 into 10? Yes, it is 100. And at the final, a into b into c, we get 21 by 100. Let us take it as first equation. And now we are going to find b into c. What is b here? 3 by 5. And what is c here? Minus 7 by 10. Multiplying these two rational numbers, we get minus 21 divided by 50. And now we are going to multiply a with b into c. What is a here? Minus 1 by 2. And b into c is minus 21 by 50. And at the final, we get 21 divided by 100. So a into b into c is equal to 21 by 100. Let us take this as second equation. From look at the first and second equation, we can able to see that a into b into c, which is equal to a into b into c. That is, multiplication is associative for rational numbers. And next we are going to see additive and multiplicative identity property. The identity for addition is 0 and the identity for multiplication is 1. For any rational number at a, there exists unique identity element 0 and 1 such that 0 plus a is equal to a and 1 into a is equal to a. 0 plus a is equal to a and 1 into a is equal to a. Let me see an illustration for that. Take a is equal to minus 3 by 7. So now minus 3 by 7 plus 0, which is equal to minus 3 by 7. Also 0 plus minus 3 by 7, which is also equal to minus 3 by 7. And hence we can say that minus 3 by 7 plus 0, which is equal to minus 3 by 7, which is equal to 0 plus minus 3 by 7. Hence 0 is the additive identity for minus 3 by 7. And further, let me see an multiplicative identity. Take a is equal to minus 3 by 7. Now minus 3 by 7 into 1, which is equal to minus 3 by 7. Also 1 into minus 3 by 7, which is also equal to minus 3 by 7. And hence we can say that minus 3 by 7 into 1, which is equal to minus 3 by 7, which is equal to 1 into minus 3 by 7. Hence 1 is the multiplicative identity for minus 3 by 7. And next we are going to see about additive and multiplicative inverse property. For any rational number a, there exists a unique rational number minus a such that a plus minus a, which is equal to 0, which is equal to minus a plus a. That is, for any rational number a, there exists a unique rational number minus a such that a plus minus a, which is equal to 0, which is equal to minus a plus a. And for any non-zero rational number b, there exists a unique rational number 1 by b such that b into 1 by b, which is equal to 1 and which is equal to 1 by b into b. For any non-zero rational number b, there exists a unique rational number 1 by b such that b into 1 by b, which is equal to 1 and which is equal to 1 by b into b. Let us see an illustration for this additive and multiplicative inverse property. take a is equal to minus 11 by 23. Now what is minus a? Yes, minus of minus 11 by 23, which is equal to 11 by 23. Now let us add these two. A plus minus a, which is equal to minus 11 by 23 plus 11 by 23, which is equal to minus 11 plus 11 divided by 23 is equal to 0 by 23, which is equal to 0. And now we are going to find minus a plus a. What is minus a here? 11 by 23. And what is a here? Minus 11 by 23. So 11 minus 11 divided by 23 is equal to 0 by 23, and which is equal to 0. From this what we can say? A plus minus a, which is equal to minus a plus a is equal to 0, which is true. And let us see the illustration for multiplicative identity. Inverse. Take b is equal to minus 17 by 29. Now 1 by b is equal to 29 by minus 17, which is equal to minus 29 divided by 17. What is b into 1 by b? b is minus 17 by 29 into minus 29 divided by 17, which is equal to 1. What is 1 by b into b? Minus 29 divided by 17 into minus 17 divided by 29, which is also equal to 1. And hence from this what we can say? B into 1 by b, which is equal to 1 by b into b, which is equal to 1. Hence it is true for rational numbers. And at the final we are going to discuss about distributive property. Multiplication is distributive over addition. For any three rational numbers a, b and c, a into b plus c, which is equal to a into b plus a into c. That is, multiplication is distributive over addition. Let me see an illustration for distributive property. Take rational numbers a, b and c as a is equal to minus 7 by 9, b is equal to 11 by 18 and c is equal to minus 14 by 27. Now b plus c, which is equal to 11 by 18 plus minus 14 by 27. Hence here it is different denominators, so we are taking LCM for 18 and 27. What is the LCM for those two numbers? Yes, it is 54, and we are converting to the same denominator. We get 33 minus 28 divided by 54. What is 33 minus 28? 5 by 54. Therefore, a into b plus c, which is equal to minus 7 by 9 into 5 by 4. We are multiplying corresponding numerators and denominators. We get minus 7 into 5 divided by 9 into 54. We get minus 35 divided by 486. Let us take this as first equation. Also, we are going to find a into b. We are going to multiply corresponding numerators and denominators. We get minus 77 divided by 9 into 9 into 2. Let us split these numbers and keep it is easier to take LCM for that. Next, a into c. We are multiplying. We get 98 divided by 9 into 9 into 3. And now we are going to add these two numbers. Minus 77 divided by 9 into 9 into 2 plus 98 divided by 9 into 9 into 3. Let us take as LCM for these two numbers. We get minus 77 into 3 plus 98 into 2 divided by 9 into 9 into 2 into 3. We get minus 231 plus 196 divided by 486. What is minus 231 plus 196? Yes, it is minus 35 divided by 486. Let us take this as second equation. Now look at the first equation and second equation. What we can able to understand? Yes, it shows that a into b plus c, which is equal to a into b plus a into c. Hence, multiplication is distributive over addition for rational numbers. I hope from this video we can able to understand the properties of rational numbers that we have discussed today. What are the properties? Closure property, commutative property, associative property, additive and multiplicative identity property, additive and multiplicative inverse property, and distributive property. I hope you all understand, and thank you, my dear children.